6. Did quite a bit of work trying to get most of what's in your book up into these slides, and so let's see if I can take my freeze button off here so that we don't miss anything. All right, and so I've tried to put most of our defining things in here so that you can go back and watch the video even if you don't have your book with you, be able to catch most of this stuff. Today we're talking about finding surface areas and volumes of cones, right? And lateral area is included in that. So a cone is a three-dimensional figure with a circular base, right? I think most of you in here know what a cone is. It's got a curved lateral surface. That lateral surface is that outside length from my base to my vertex. The circular face of a cone is the base of the cone. The vertex of a cone is the point opposite the base. The altitude of a cone is the perpendicular segment from the vertex to the plane containing the base. Right? So there's a lot of specific terminology here. What's going to be easier for you is to see this picture right over here where it's going to point out what everything is. Our vertex is obviously the point at the top. On our base, the line that's going to go from where our altitude connects with the base is going to be our radius. It should be perpendicular in the event that what we have is a right cone. Now, if we can also have an oblique cone where it's somewhat tilted, okay? You ever go to like a state fair or something like that where instead of having cups, you ever drink out of one of those like cone type paper cups, right? Those things are easy to kind of get twisted or whatever. That would make it go from a right cone to an oblique cone pretty quickly. Okay, so our altitude is our line that goes from that vertex to our base that's perpendicular to it. So sometimes if we're dealing with an oblique cone, our altitude will actually exist outside of the cone. Let's see, I'll draw a for instance here in a little bit. Maybe I can give you one here. But let's say I've got a base here, and I move my point over, okay, then this is no longer perpendicular, okay? In fact, what I might find is that, let's see, if I do it extremely enough, let's say that my vertex is out over here, okay, then my altitude is actually all the way outside of that oblique cone. Okay? All right, so if the altitude of a cone has an endpoint on the center of the base, then it is a right cone. In an oblique cone, the altitude does not intersect the center of the base, right? It could still be inside the base, but it's not going to be at the center of it. It could be even all the way outside of that cone. The same way whenever we have gone to find the area of certain triangles, sometimes that height of that triangle is outside of the triangle, okay? So we've got a vertex, an altitude, a slant height, and a radius, and we're going to use all of those to find different components, different measurements of cones. The slant height of a cone is the distance from the vertex of the cone to a point on the edge of the base, right? So it's on that outside edge. Okay, it'd be a line. If we pulled out one of those paper cone cups, right, there's going to be a seam where that paper connects. That seam would represent the slant height of that cone, okay, to a point on the edge of the base. The radius of a cone is the radius of the base of the cone. So from the center of the base to the outside edge of the base. Okay, hopefully all of this is making sense so far. Yes, no, maybe. It's second hour. We're all still asleep. Okay. All right, so the very first thing we want to be able to find is we want to be able to find lateral surface area. The lateral surface area here is representing, again, if I go back and I use the illustration of this paper cone cup, if I tore that seam and laid it out, right, actually what we would find is that, you know, that is going to end up looking somewhat like this, right? It's going to, and where I'm going to pull those edges together and it's going to end up making this cone. But this is the area that if I tore it all apart, that's what it would look like. But we don't have to do that, all right? We have a formula, and it is this. It is pi times the radius times the slant height, where this little L here, which I know it's somewhat hard to make out, especially whenever you type it up. It looks just like an I, but it's a lowercase l. So if you need to, write it off as pi r l. Okay, that is the measurement or how we're going to find slant height, or sorry, lateral surface area. What lateral surface area will not include is the area of the base. So if you ever had an ice cream cone, right, this is the same concept as that paper cone cup, right? If we put something across the top of it, obviously we couldn't put any ice cream in it, right? So that cone is representing a lateral surface area. Okay, does that make sense? All right, so that's our formula for lateral surface area. It's a formula that you need to know, that you need to write down, that you need to be able to use. Okay, so put it down somewhere where you can use it. Lateral surface area of a cone equals pi RL, you know, or pi times radius times the slant height. If you need to be even more specific, be as specific as you're going to need to be. Okay, because I'm going to refer back to this, and I'm going to ask you, hey, what's the formula? Because we're going to get questions here in a little bit. What is the lateral area? How do I find the lateral surface area of a cone? You're going to need to tell me it's pi times radius times the slant height. Are we understanding each other? All right, we'll move on. Okay, we'll look at how to use this in a little bit. Now, like most of our surface area and lateral area problems, lateral area or lateral surface area always leaves something off, right? Whenever we talked about cylinders, we left off the two bases. When we talked about prisms, we left off the two bases. Lateral surface area always leaves things out, whereas surface area encompasses the area of all sides. Okay, so in most of these, and you're going to see it again today, surface area is lateral area plus what lateral area was missing. Okay, so you're going to use that formula and you're going to add something to it. So surface area of a cone is the total surface area of a right cone is given by this formula where capital L is the lateral area that we found on the previous slide and B is the area of the base polygon. They leave it just real simply as this. Surface area equals lateral area plus the area of the base. I don't really like that because for the most part it makes some assumptions that you're automatically going to remember what B is in terms of the formula. So the full formula for finding surface area of a cone is pi r L plus pi r squared. Okay? Pi r squared is the area of that circular base that that cone has. Okay? So if I need to find the surface area of this little blue cone here, okay, I know you can't see it on the video or whatever, okay, but I'm going to find the area of this, right? This is just lateral surface area, what I'm representing here with blue, right? If I want the surface area, I'm going to have to add this on to that. Okay, how do I find the area of this? Pi r squared. Okay, now I have the whole thing. Does that make sense? All right, so if you can visualize it and you know what different components actually mean, it's a whole lot easier to remember the formula. Okay, now pi RL may not be so easy to remember, but we for sure ought to be able to remember pi r squared. Okay, so if I'm writing something down, I'm probably writing surface area equals pi RL plus pi r squared. And again, if I need to, I'm going to make a note about L being the slant height. I may even draw a picture of a cone and point to the slant height so that I'm not confusing it with altitude. Okay? Altitude is true height, whereas slant height is the length from the vertex to the outside edge of the base. Okay, volume of a cone. Now you'll notice some similarities between this and how we found the volume of a pyramid, right? We found the volume of a pyramid using basically the same thing, which was the area of the base polygon times the altitude divided by 3. This is the same thing, but because it's a cone, we're going to find the area of the base differently. Okay, the volume V of a cone is given by this formula, where big B is the area of the base, which we're going to use what formula for big B? What? Pi r squared, okay, is the area of the base, and H is the length of the cone's altitude. This is where we're not using slant height. We use slant height for surface area and lateral surface area. We use altitude for volume, okay? So that's why I capitalized altitude so that you knew that there was a difference. We're not using slant height here. So If I'm going to write down a formula, I can write it down a couple different ways. I can write down 1/3 pi r squared height, or pi r squared height divided by 3. And I think both of those look better than what you see up there. The only problem is that it's really hard to type this type of equation, what you see there in blue, into Smart Notebook. And so I knew I was going to come across it. It's like, you know what? I'm just going to clarify it. I'm going to hand write it out there for them whenever we get there. Okay? Any questions up to this point so far? Okay, I see several of you writing some notes down. I think that's great. Okay. All right. I like several of you guys using your Chromebook to type a lot of this stuff in. Okay. Now that being said, I don't know. I enjoyed that. It's about the cones. All right. So let's see if we can solve some problems. Hopefully, I pulled this stuff up. Doesn't look like I did actually. You have to know something about Parks and Rec in order to get that, I guess. When you get to make a choice, always go with the Maverick. Oh, goodness. Tech kids came by the other day and asked me if there was anything that I wanted tech-wise. I'm like, yeah, a new computer, a new tower, a new monitor, the whole thing. Because we got nothing going on here. Yeah. Well, and I think, oh, hold on. Are we moving? There's life? Here we go. So yeah, I kind of doubt that I get anything because I think maybe even this smart board might be newer, but my monitor's not, and my computer is certainly not. I should never have complained about the computer that I had. The computer that I had before this one had a floppy drive. And so I was like, oh my goodness. And then they get like, okay, we're going to get you this one. And it's worse. It's way worse. All right. Hopefully you guys have something that looks like what you're going to see here in a second. I hope so. I think I got it sent to you. I tried to, let's see, something like this. You guys have this? You're looking at that? Great. All right. So most of this, we don't actually need to draw a picture for stuff we can't see because we're just looking for the elements that are going to go into the formula that we're going to use, right? So an ice cream cone has a diameter. Well, that should be a red flag for me, right? All right. As soon as I see diameter, we're trying to use stuff. Do we ever use diameter in any of our formulas at this point? No. So we know right off the bat that's going to have to be converted to what? Radius. And how am I going to do that? Divide by 2. Very good. It's got a slant height of 8.8. We want to find the lateral surface area of the cone. Use 3.14 for pi. Can anybody tell me what my formula is for lateral surface area? Erica. Okay. Pi times radius times slant height. Okay. Well, what are we going to use for pi here? 3.14. Okay, so we can do that there. What is my radius? Can anybody tell me what radius am I going to use? 5.2. I heard something else back there. I don't know what that was. And then L is what? 8.8. Okay, well, rather than me doing this for you, I want you guys have got calculators, right? Get those calculators out. I want you to tell me what your answer is. Okay? Minor when you've got it. Sorry, I was pointing at him as your hand was going up. Okay, we want, let's round that to the nearest tenth. 143.7. Yep. 143.7 centimeters squared. Do we understand what we're doing at this point? Good, good. Everybody should be working these out, okay? All right, let's come on down to the next one. You've learned some flashy tricks. Just don't make the critical error. It's all about the cones. All right, find the surface area of this cone. All right, I need to find surface area, which means first and foremost, I need to have my formula. Aaron, can you tell me what the surface area formula is? And I want it expanded. I don't want the really, really short version. I want the expanded version that I gave you. No. Don't remember? Okay. Mariah, you had your hand up back there. Do you remember how to find the surface area of a cone? Yeah, I don't want the reduced one. I want the expanded version. It's going to give me everything that I need. Minor? Pi RL plus pi R what? Squared. All right, so Aaron, you need to write that down, right? So you have that formula to work with, right? Because next time I might ask you again. Okay, pi RL plus pi R squared. We want to find the surface area. We're going to use 3.14. So let's start off with that. So we got 3.14. What's my radius here? 6.6. What's my slant height? 20.4 plus what? 3.14 times 6.6 squared. Okay, I'm going to put it in there so I don't end up squaring up a whole bunch more stuff. All right, so you calculator people, let's get to it. Let's see, Matt's got an answer. What'd you get? A. Okay, what is A? You got 559.5 centimeters squared. Did anybody else get that answer? Some of you others are working that out. Okay, you want to get 555, or sorry, let's see, 559.5. All right, let's come on down here. Find the lateral and surface area of a right cone with radius of 5 inches, height of 12. Give your answer in terms of pi. So are we going to multiply pi into things? No. Okay. I'm going to scroll up so we got some room to work here. Of a right cone with a radius of 5 and a height of 12. The thing I don't like about this is that height is easily confused with altitude. What they mean here is slant height, because that's otherwise we don't have enough information to work with. So this is referring to slant height being 12 inches. So let's start off again with lateral area. Darian, what is my formula for lateral area of a cone? Stop. Lateral area is the smaller formula, right? Surface area is what? Aaron? Okay. Okay, good. So we have these two formulas that we're going to use. We have lateral area and we have surface area. So our lateral area is pi. What's my radius here? Oh, Caleb. We're on this question down here. 5. So we got pi times 5. What's my slant height? 12. All right, so can I go ahead and solve my lateral area in terms of pi? What's 5 times 12? 60. So my answer here is 60 pi inches squared. Okay, now the nice thing about having a question where we have to solve lateral area and surface area is, do I need to solve pi L again over here? No. What do I already know? I already know that this is 60 pi, correct? Plus pi, what's my r squared here? 5 squared. Okay, so I got 5 squared. So that's 60 pi plus what? What's that? 25 pi. Okay, so finally, what is my surface area? 85 pi inches squared. All right, so we're looking for a lateral area of 60. Did we do something wrong? I'm trying to see a 60 in here. Oh, I see what we did. So they actually, they are referring to this as the altitude. So which means we've got to do this. That's embarrassing, right? Do all of that wrong. All right, so what we have to do is this is, if this is 12 and it's a right cone and this is 5, my slant height is that guy right there. Right? How do I find that? Pythagorean theorem. Okay, so 12 squared plus 5 squared, okay, equals c squared. So we have 144 plus 25 equals c squared. So we have what, 169? What happens whenever I square root 169? 13. So c equals 13. So what we're going to use then is we're going to say L equals 13, and we're going to start over. All right, so lateral is pi r L, and I'm going to kind of try to catch this up here. So that's pi times 5 times 13, right? Surface area is pi r L plus pi r squared. Okay, what's 5 times 13? 65 pi inches squared. So we already know that this part over here is 65 pi plus, that's still 25 pi, right? So pi 5 squared okay, what's 65 plus 25? So we get 90 pi inches squared. Okay, we got all that straightened out. Lateral area 65, surface area 90. What is my answer there? B. All right, so even whenever I make a mistake, it's still a learning opportunity because we made an assumption it was incorrect, right? We found that out because the answer that we got wasn't anywhere in there. So we had to go back to the drawing board. Okay, cone has a radius of 4 inches, slant height this time of 12 inches. Calculate the lateral area of the cone using 3.14 for pi. All right, hopefully at this point you guys can put together your formula and solve the question, right? All right, so I want you guys to solve this one on your own. Miss Ayel, when you have an answer, right, I want you to tell me what work you did. Okay, so what did you plug into your calculator? Times 4 times 12. Okay, 3.14 he used for pi, 4 he used for his radius, 12 he used for his slant height. He plugged that in and got 150.72 inches squared, which was correct. All right, last couple of questions here. Okay, calculate the surface area of a cone and a slant height with a slant height of 8 inches and a base radius of 4 inches in terms of pi, right? Let's see, Austin, what is my formula for surface area? Plus PR squared? Pi r squared. Oh, got me all messed up there. Okay, so let's plug in. Okay, we're solving in terms of pi, so we'll leave that the way that it is. We're looking at question number 5. So what are we using for our radius? 4. What is your slant height? 8. Okay, what's 4 times 8? What's 32? Okay, so we got 32 pi. What's 4 squared? So we have 16 pi. What's 32 pi plus 16 pi? 40? No. 48 pi inches squared. Okay? Knowing the formula is everything with these. Okay? We're really, so far, we're not getting even into volume until question number 6. So hopefully you guys remember your volume formula. All right, let's see, who have I not really picked on today? Casey, can you tell me what the volume formula for a cone is? 1/3 times what? 1/3 times base times, okay, so the base of a cone is what formula? Area, so how do I find the area of the base of a cone? How do I find that B that you're talking about? What shape is the base of a cone? What's that? It's round, okay, so it's a circle. How do I find the area of that circle? Or any circle? Class, how do I find the area of a circle? Pi r squared, okay, times our altitude or height, okay? All right. Or you could do pi r squared height divided by 3. Let's see. So let's do pi. What's my radius, Casey? (1.3). What's my altitude? 6.6. And we can use that here, right? We don't have to convert that to slant height. Divided by 3. You got a calculator. Do all of the top. Do pi times 1.3 times 6.6. Get an answer there, and then divide it by 3. Tell me what you get. And because it's volume, we want it to be in inches cubed. Ooh, we forgot something, didn't we? I need to square that. Okay, hopefully when it's all said and done, how many of you guys got this answer that's up here? 2, 3, 4, 5, 6, okay, good. We should get 11.7 inches cubed. All right, with that, we're going to hit stop on our video and you guys can get started.